Hey, what's up? So in this new video, we are once again going to talk about retain cycle, but this time I want to focus on a syntax that, while it will look super safe on the surface, actually has all the potential to create retain cycles inside your app. So fair warning, if you are already using this syntax, well, this video might make you cringe a little bit. So let's begin by taking a look at this class. So as you can see, this class, well, the instances might be freed or not depending on what we do inside the class. So first you can see I have a subject. So here I am using combine. This way I have a way of asynchronously providing new values through this subject. Then I have a cancelable, so a set of any cancellables in order to store my combine subscriptions. And finally, in the init of the class, you can see that I'm subscribing to new values in my subject. And the way I do it is that I write a closure in which I call the use instance method. So if you are familiar with Swift, you probably already have spotted where the issue is in this code. Is that here, this closure captures self. So the closure creates a strong reference to self. And well, this closure is being stored in the set of any cancellables, and the set of any cancellables is also part of self. So what's happening is that self owns the set of any cancellables that also through the closure owns self, and this creates a retain cycle. So to convince ourselves that there is indeed a problem, I'm going to run the code. So just to show you where the instance of the class might be freed is created, it's done right here in the app delegate in the method application did finish launching with option. And as you can see, the instance is a local variable that goes out of scope immediately after being created. So normally, unless there is of course retain cycle, the instance should be deallocated immediately. But let's run the code and see what happens. So as you can see, if we take a look in the console, you can see that hello world is indeed printed, but the print that is in the dinit is not being called, which shows that indeed we have a retain cycle in our app. And in Xcode, we can actually visualize this retain cycle. So to do it, we just need to display the memory graph. So we use this button right here in the debugger. And you can see that the retain cycle is visible. So here we have our instance of might be freed. As I was saying, it possesses its set of any cancellables. In the set of any cancellables, well, there is the any cancelable that correspond to the subscription. Then there is the subscription itself. The subscription uses a closure, and the closures strongly capture self. So we have our retain cycle. But if you have some experience with Swift, well, you probably already know the easy way to solve the issue. So we just need to capture self weekly. So like this, I add week self. Now self is optional. And now if I run my code again, well, you can see that indeed the issue has been solved because the closure no longer captures a strong reference to self. There is no longer a retain cycle. And indeed our instance is being freed as shown by this print statement in the console. But as always, whenever we use weak self, well, we need to add some extra syntax. And it's always tempting to try and find some ways to get rid of this extra syntax. And if you know a bit about Swift, well, you might know that you are able to pass in a method or a function as an argument to another function. So for instance, here, instead of disclosure, I can actually pass a reference to the method useData. And as you can see, this code builds, so it's perfectly valid Swift code. However, well, while on the surface it looks super safe from the point of view of a retain cycle, because after all, self is written nowhere on this line, well, if I run the code, we're going to be surprised a bit. Because as you can see, when I run the code, well, it shows that the init is no longer being called, even though it doesn't seem that self is being strongly captured anywhere. However, well, if we once again take a look at the memory graph, we're going to get a hint on why we have this issue. So on the memory graph, well, something a bit surprising is happening is that our retain cycle is still present, and it's actually the same one than before. So our instance has its set of cancellables. In it, there is a cancelable, the subscription, and there is once again a closure that does capture a strong reference to self. And well, it looks kind of weird because there is no closure right here. We are just passing a reference to the method. However, if we think about it, well, something is actually weird here because this method, well, it's an instance method, meaning that in this method, it's perfectly valid to use self. So in a way, we are able to use self. So this self, well, it must come from somewhere. And this is where the tricky part is that whenever you are passing the reference to an instance method, you are actually passing a closure that has already captured a strong reference to self in order to be able to call the instance method, because the instance method, to call it, well, it needs to be called on an instance, so it needs an instance of self in order to be called. And this is what's super tricky, is that while the compiler allows this syntax, well, there is nothing that forces us to write self. For instance, the compiler could force us to write self like this, but it doesn't, and that's what creates this, well, we could say, kind of dangerous syntax because it creates a retain cycle, even though when you take a look at the code, none of the usual hints of a retain cycle are present. And that's all for this video. So once again, we've seen that retain cycle are definitely a tricky topic in Swift, especially when we consider that kind of syntax. Now, I must say, I'm super curious to have your feedback on this topic. So if you were already using this syntax in your app and you were not aware of the risk in terms of retain cycle, well, please let me know in the comment, give me all the details that you think could be useful. I'm really super curious to know about it. Thank you for watching this video and see you next time.